So today we're going to talk about how aPriori can give us insight into manufacturing cost drivers during the development process. And we're going to be costing this bracket V2. So I'm going to start by pointing to our 3D CAD model. And to develop a cost estimate in aPriori, I need to provide a handful of inputs. First of all, a high-level classification of how this part is made. It's a sheet metal part. Second, we need to tell aPriori where this part is going to be made, which for this part is going to be made in the United States. So I'll select that virtual production environment. We then need to tell aPriori what our material is going to be if that's not specified in the CAD model. So I'm going to select the steel cold work 1010. And then finally, we need to tell aPriori how many of these we're going to be making per year, which we're going to make 5,000. Then we click the cost button. And once aPriori has finished costing, which will take seconds to minutes, we can view our cost drivers. So we can see very high-level cost drivers in our first screen, where we can see that about 60% of our cost is coming from material, while the rest is coming from various manufacturing costs. We can also see a breakdown of the manufacturing processes and their cost contribution. So we can see the features that are being made on a laser punch, we can see the bends that are being made on a bend break, and we can see all the holes that are currently being machined. Now, to further understand our cost drivers, we can view our design to cost, and we can see potential manufacturing issues, such as our bend that has a flap size that is too short to be manufactured. And we can see issues with holes being too close to the blank of the part and also too close to various bends on the part, which can be manufacturing issues and can also drive costs up. Other manufacturing cost drivers that we can see are things like tolerances that are driving cost and driving additional machining. So I can see I have 12 tolerances that are requiring additional machining. And for each one of those features, I can see its current tolerance and the tolerance I need to back off to in order to remove the need for machining. So if I back this 10,000 tolerance off to a little bit higher than 50,000, I can remove the need for machining, greatly reducing my manufacturing complexity and my overall cost to my